Next application is Transient Circuits. This is one application ng first order differential equation. So you have here a circuit R and C. So na meron tayong electromotive force here. So once the switch is closed, say for example, the switch is closed, there is a sudden kumbaga gulat. So there is a time it takes for this current na pumunta sa kanyang steady state is what we call the transient response. So ito yung time na nagkakaroon ng pagbabago ng voltage at saka ng current. So usually this happens kapag meron na tayong capacitor at saka inductor sa isang circuit, since we all know that meron siyang time it takes for it to be fully charged, kasi alam naman natin na ang capacitor ay nagkakaroon ng charging capability. So kumbaga nag-i-store siya ng energy. So when we talk of transient circuits, there are three components na nakikita lang natin. So first is the resistor, the second one is the capacitor, and inductor. So syempre alam naman natin na ang symbol niya ay ganun. Ang capacitor ay ganyan kapag ka non-polarized, kapag ka naman polarized ay ganun. So capacitor pag polarized, capacitor pag non-polarized, kapag ka inductor it's a coil or a choke. So, pag-uusapan naman natin ang voltage drop across each. So, syempre alam naman natin na kapag ka-resistor, ang voltage across it is defined by Ohm's law. So, from Ohm's law, I is equal to V over R. So, voltage across that is therefore equal to the product of I and R. So, this is I times R. And the voltage across the capacitor is given by, so this is VR, itago na natin sa pangalang VR, that's voltage across the resistor. This is VC, voltage across the capacitor, which is 1 over C integral of I of t dt from 0 to t. So hanggang sa ma-full charge yung time para ma-full charge yung capacitor. And then an inductor VL is equal to L dy dt. So, L multiplied by the derivative of the current with respect to time. So, but since meron tayong principle noon na ang definition ng current is the rate at which the charge is transferring per unit time, so we can replace I with dq dt. So, this gives you 1 over C integral of dq dt. So, then dt here cancels out, since I is actually derivative of Q with respect to T. So instead of I of T, I can replace it with by its definition. So integral and derivative cancels out. So this is simply Q over C. So therefore, VC is simply VQ over C. Yung Q is the charge. So yung charge in that particular capacitor. So pag-usapan natin ang mga unit. Ang unit ng resistor ay ohms. Ang capacitor ay farad, ang inductor ay Henry. So, kapag ka-charge, it is coulomb. So, yon ang mga usual na units natin. So, let us try to apply this, or let us try to find the behavior of an RL and an RC circuit. So, pag-usapan lang natin ngayon ay yung RL at saka yung RC, since ang napag-aralan pa lang natin ay mga first order differential equation. So, as you can see, if I have here a combination of R and C, magkakaroon tayo ng IR at saka ng QC. So, for which I is the rate at which the charge is transferring per unit time. So, meron tayong first order differential equation. Pagka naman pinagsama natin ang R at saka ang L, meron tayong derivative of I with respect to T. So, ibig sabihin, kapag pinagsama natin yun, that is also a first order differential equation. Pagka pinagsama mo na yung tatlo, magkakaroon na yan ng higher order or second order differential equation. So, but since ang napag-usapan pa lang natin ay mga first order, so we will discuss first the combination of an RL and an RC circuit. So let us try an RL circuit. So for an RL circuit, say I have here E This is plus to minus. This is R, and then this is the inductor L. So you have an electromotive force here, you have an R, and then you have an L. I forgot na naman ang switch. So wala yun. So once the switch is closed, doon na yung magkakaroon ng current na magpa-flow kasi the drive na nung electromotive force yung current na yung charge na mag-flow from positive to negative, ang tawag doon ay conventional flow. Pero kapag ka from negative to positive, ang tawag ay electronic flow. Electronic flow. It's electron flow. So by principle of Kirchhoff voltage rule, the summation of voltage input minus the summation of voltage drop must be equal to 0, or the summation of the voltages around the closed loop is equal to 0. So the voltage input here is E, so this is E minus the voltage drop, so that's voltage summation. So dapat there are two voltage drops involved, voltage across the resistor and voltage across the inductor. So that is summation. So minus voltage across the resistor plus voltage across the inductor is equal to 0. So that gives you VR plus VL is equal to E by transposing this negative quantity VR plus VL on the right side of the equation. But VR, voltage across the resistor, is given by I times R, and the VL is L multiplied by the derivative of I with respect to T is equal to E. So rearranging by dividing that all by L, so this gives you di dt plus I multiplied by R over L is equal to E over L. So what I did is dinivide ko siya by L and then rearrange accordingly dun sa form ng linear differential equation. So if you remember, LDE, so dy dx plus y times a function of x is equal to a function of x. Recall, linear differential equation. So this is dy dx, y, this is the dependent variable, multiplied by a function of x is equal to g of x. So as you can see, if this dependent variable I ay mayroong multiplier na r over L, which is a function of t, and d over L as a function of t. So therefore, this is a first order linear differential equation. So, di ba, pag ang na-discuss natin noon, kukunin natin ang integrating factor. So, that's e raised to integral of f of x dx. So, in our case, that's e raised to integral of r over L dt. So, this therefore is your f of x, so which represents f of t na. So, that is kaya dt yon. Kasi ang independent variable natin dito ay t. So, this is equal to e raised to r over L t because integral of dt is t since r over L is a constant. So, r is the resistance and L is the inductance. So, as per solve for the integrating factor, what we do next is to multiply this integrating factor in our original differential equation. May I just rewrite first our differential equation, di dt plus I multiplied by r over L is equal to e over L. So now next step is to multiply this all by our integrating factor e raised to r over lt. So e raised to r over lt, e raised to r over L of t. So multiplying our LDE by our integrating factor, this is equal to derivative of the integrating factor and the dependent variable. So derivative of the product of the dependent I and our integrating factor R over L of t, which is equal to E over L, E raised to R over LT. So now, if I am going to integrate both sides, so dt, so I just need to provide here to satisfy my u, this is r over L, so I need to provide r over L because the derivative of r over Lt is r over L dt. So since I provided r over L, so I need to provide L over r outside to compensate r over L doon. So this now gives you I e to the r over Lt is equal to E over R, E raised to R over LT plus K. So, I put K kasi mamaya magkakaroon tayo ng capacitor, baka ma-confuse tayo dun sa capacitor na C. Kaya I put K na lang for a constant. So, isolating I by multiplying this all by e to the negative r over LT to cancel this out. So that gives you I is equal to e over r. And by multiplying this by that cancels out. So that gives you plus k e to the negative r over LT. So this is in terms of ampere. So this is the general solution. So this is our general solution. But so since at time t is 0, so syempre naka-open pa yung ating switch. So I mean, kapag na-close natin yung switch, that's the very time na magkakaroon lang tayo ng charge na magfo-flow or the current flow. So therefore, at time t is 0, the current is assumed to be, so the current in that particular circuit is 0 since wala pang tatakbong current dahil nga hindi pa na-switch yung switch. Hindi pa na-switch on yung ating switch. So at time t is 0, your current is equal to 0 ampere. So substituting, that 0 is equal to e over r plus k e to the negative r over l times 0. But e to the 0 is 1. So k here is now equal to negative e over r since you are to transpose that e over r there on the left side of the equation. So substituting sa ating general solution, magkakaroon tayo ng particular solution. I is equal to e over r minus e over r e to the negative r over LT ampere. So therefore, our expression para sa current as a function of t is e over r times the quantity 1 minus e to the negative r over LT ampere. So that will serve as our working equation. So current I of t is e over r times the quantity 1 minus e to the negative r over LT. So that will serve as our working equation to solve for the current through this particular circuit RL. So ibig sabihin, kapag at an given time t, say for example, at time t is equal to 1 millisecond, so I can now solve for the current. So at time t is 1 second, so how much is the current? So isa-substitute lang natin yung given dun sa aking expression na nagawa. So always remember this, IT is e over r times the quantity 1 minus e to the negative r over LT amperes. So now, how about if we are going to deal with an RC circuit? So, paano kung RC naman ang pag-uusapan natin? So, let's talk about RC circuit. So, ang RC circuit naman. So, si RC circuit ay resistor and capacitor naman ang involved. So, I have here an electromotive force, plus to minus E. This is the resistor and this is the capacitor. So, let me have a switch here. So, this is the switch S, the resistor R, and the capacitor C. So, again, by the time the switch is closed, so there exists current. So, by Kirchhoff voltage law, KVL, E is equal to VR plus VC. So, the summation of voltage around the closed loop is equal to 0. So, that is E minus summation of voltage drops is equal to 0. So, I transpose the summation of voltage drops. So, since there are two voltage drops, voltage across the resistor and voltage across the capacitor. Now, I am to solve for E, which is equal to VR, which is I times R, plus VC, which is Q over C. So, but then by definition, I is equal to the rate at which the charge is transferring per unit time. So, I can now replace I with dq dt. So, E is equal to R times dq dt plus Q over C, since I is dq dt. Then dividing this all by r, so this is dq dt plus q multiplied by 1 over rc is equal to e over r. So again, what we did is dividing this all by 1 over r, or multiplying by 1 over r, or dividing by r. So dividing by r, so that gives you dq dt plus q1 over rc is equal to e over r, which is a first order linear differential equation. So first order linear differential equations. So katulad nung ginawa kanina, I need to get the integrating factor. IF is e raised to integral of 1 over rc dt. So this is e to the t over rc as our integrating factor. So again, multiplying our LDE to our integrating factor e raised to t over rc gives the derivative of the dependent q and the integrating factor e to the t over rc. So again, if you wish to find the detailed discussion here, please refer to linear differential equation. Is equal to e over r e to the t over rc. So integrating the two gives to satisfy my u and my du, I need to provide 1 over rc and compensate with rc. So multiplying by 1 over rc and compensate it with, or by multiplying rc. So this integral and derivative cancels out, gives q e to the t over rc is equal to r cancels out. So magkakaroon tayo ng ece to the t over rc plus constant k. So again, multiplying this all by e to the negative t over rc to cancel this out. So that gives you q is equal to ec plus k e to the negative t over rc coulomb. So hindi ko nilagay as c yung coulomb kasi nga baka ma-confuse ulit tayo with c na capacitor. So instead of writing C for coulomb, I wrote COUL, short for coulomb. And then since that's the general solution, so again, it is always assumed unless otherwise we are told to that the time t is 0, the charge in that capacitor is also 0. So it always assumed to be 0 unless otherwise we are told to. So at time t is 0, the charge in that particular capacitor is 0 coulomb. So substituting to our general solution, let me rewrite that first. So that's q is equal to ec plus k e to the negative t over rc. So that's our general solution. So substituting our initial condition that at time t is 0, your q is 0. So 0 is equal to ec plus k e to the 0 over negative rc is e to the 0. Then k here is negative ec. So since k is negative ec, transposing that there, so substituting to our general solution, q is ec minus ec e to the negative t over rc coulomb, or q is ec times the quantity 1 minus t over rc coulomb. So this represents the expression for the charge in the given capacitor. So should you wish to find the current across the capacitor, or current through the capacitor, I just need to take the derivative of this one. So, di ba, as per definition, the derivative of q with respect to t is actually I of t. Should I wish to find the current through it, I just need to take the derivative of this expression. So that I of t is equal to ec times the derivative of 1 is 0 times the derivative negative t over rc multiplied by negative 1 over rc. So taking derivative with respect to c. So therefore, I of t is equal to e over r e to the negative t over RC ampere. So that must be our expression para sa current through the capacitor in that particular circuit. So this is, yeah, this is correct because C cancels out. So magiging E over R, e to the negative t over RC because negative times negative is positive. Okay, so ibig sabihin, in this particular circuit, the behavior of the current and the charge in the capacitor are expressed or defined by these expressions respectively. So let us try to solve some problems